There's some serious hot air coming out. Well, I didn't check the thermostat. Yeah.
It always blows cold air.
Yeah, this is cold.
It's cold.
This is hot. How?
Maybe that's the one I was thinking about. I don't know. I turned it down a degree, we'll see.
I like to joke that the temperature in this building represents the weather in Wisconsin. Like, just, it's highly variable.
I guess so, yeah.
Yeah, I did that.
All right. We
And
can
it's
get
really easy for me to scroll to a certain time if you want to just pause it. And go
Yeah,
back.
that sounds good. We can get started for Weather Watch today. So it is Valentine's Day. So I'm going to wear these for a single minute while presenting. One, because they are very hard to see, and two, when I look at this, I see black or like green, and then like pink, and that's it. But I wanted to wear them because it's Valentine's Day. So we'll start with a look at the week. I'll let this restart here. It's been an interesting week compared to what we had last week. We got snow, which is good. I'll point that out here. But first I want to start with, once this restarts here, at the very beginning, I'll watch Texas. So once this restarts, there's a cold front that moved through the central part of the United States. You'll see on the 8th here, there it goes, right there. So if we could pause, please, and go back to the 8th at like 17Z. You can see this from space. So if you see that little Boeing feature, that's the cold front. I moved all the way through central part of the United States, but Texas was the only place that really had a temperature difference, so you could see where it's warm. And if we just step through with the arrows a little bit, you can watch it march southward. So you see that leading edge. It even spurred, if we go back a little bit and watch New Mexico here. So this cold front moved south. Keep going back, please. Let's see here. This cold front moves south. There's mountains in New Mexico, and it spurred snow because you had really cold air overrunning, warmer air that was in place. So that got pushed up. There's mountains there, so it added extra lift, and you get snow produced from this cold front moving through. So you can see it from space. Again, second time we've had that, which is pretty cool. This thing, then we'll watch if we just keep stepping through and go to the next day. You'll see it propagates all the way through the southeast. You can see this line. But then it gets to the Gulf Coast. The Gulf Coast is still warm, so it doesn't get anywhere past that. And then we just get a return flow of warm air. But you can see that whole progression as it moved through. That was cold front number 1, which I'll point out. So right there, you can see it march through the country. Pretty cool. The second thing, I check my notes here. Oh yeah, if we go back, let's see. Yes, right around here. So the same time this cold front is moving through, here we have our piddly snowfall we got on Saturday. I don't even know how much we got. I don't think it was an inch or anything. But if you watch this system, it's nothing over much of the United States. It'll come over the Atlantic, and then watch this thing develop here. So it develops a nice comma shape, classic cyclone. You can see it's a really nice cloud extending all the way into the Atlantic, and then becomes a gigantic cyclone. So even though we got nothing from it, became a pretty cool cyclone. And you'll watch this progression. If we watch it stepping forward here, it spins, it hangs out just south of Greenland, which is right up here. Continues to move towards the pole, which is a little weird. And you'll see as it does, the cold air in the poles will begin to get dislodged southward. So this same system that brought us snow, if you even call it that, it got an inch of snow, became a cyclone. Now it's sitting up over Greenland, and out ahead of it you can see all this cold air. And this is getting near current. So this is the source of our cold air, was that cyclone moved poleward, moved all the cold air southward. That's going to be one of the contributors for our cold air coming. You can see how cold it is. These temperatures are, maxing out any cold temperatures besides the really strong convection. That's all just the land. That's how cold it is. And some of these temperatures extended down into the United States. I know places in North Dakota and Minnesota got close to -40. That's the temperature you don't have to say if it's Celsius or Fahrenheit, because it's -40. They're both the same, so that's how cold it was because of the cyclone gave us some snow, moved over, developed really nicely, and then dislodged this cold air. And you can see it if we go to current now. So here's the cyclone. You can see if you make out where it's cloud-free, it's even warmer at the poles than it is down in the prairie provinces of Canada because of that thing. And this is setting up our cold air and cold snap that we will have coming up here. That same cyclone. So it's sort of just paraded around from Wisconsin all the way to the pole and is beginning to move back down to our region here. So that's cool. Let's see what else. Oh, and our snowfall we got. So let's see this thing again. Here was our main snow event. You can see it's largely unorganized as it moved through the central portion of the United States, kind of just unsettled. We got 3.6 inches at Madison, which makes us the third least snowy for any calendar year, any calendar winter. So something good came from it. We won't be setting, very low snowfall totals, but you can see we had a pretty nice snowfall. Places like Racine, which is right along Lake Michigan, got 8 inches of snow, so pretty good snowfall for them. A lot of it was, you can see it was just southwest to northeast bands of snow moving through our region, and that band set up just to our south and east, and so that's where the highest snowfall totals were. As most of the snow was just this, it propagated from the south, set up this band, and then those are the heaviest snows. And in its wake, you can see, here's our snowfall, here's the cold air beginning to wrap around behind it as temperatures dropped. At the same time, if we could go back to like 2 UTC, I think it is. A cool thing right here, you can see the land was so cold that you can make out the Missouri River in South Dakota. And if you just step back and forward, you'll see this thing doesn't move. So that's a topographical feature right there. That's the Missouri River. And this is the same time it was -40 up in North Dakota. So pretty cold, I should say. You can see that, the river from space. What else here? Here we go. Okay, so we had snowfall the same day. If we just step forward to like 12 UTC, you'll see in California, there was a nice cyclone that moved on shore. Central pressure was around 983 millibars, so a pretty decent storm. Look at all the moisture as represented by these really high clouds. Snowfall totals, I'm specifically focusing on like Colorado, so well removed from the main moisture. 3 to 4 feet of snow projected in Colorado, so you can imagine the mountains in California got slammed with another 100 inches of snow, I'm sure. And places in Nevada as well. Really nice development, and you can watch if we just step forward, we'll see this thing. It doesn't look as nice as it moves over the topography, but you can see how unsettled it is. This is a lot of just moisture being pushed up over these mountains. We lose that nice cyclonic circulation, but you can still make out that there's a lot of just unsettled weather. The moisture from that system is going to bring us our snowfall tonight. And so you can see it moved over the Four Corners region, and now we're into that, some of the moisture from that same system from California. Other things to make out, if we step back just a couple hours here, you can see the mountain ranges, which is pretty cool. So specifically the Front Range of Colorado, if you just step forward a little bit, you'll see there's always this north-south line between where there's a lot of moisture, high clouds moving. They go up the mountain, they produce snow, and then on the lee, they dry out and warm up. And so you'll see this line just persist, especially in Colorado, but I think you can even sort of see it in New Mexico as well. But so a lot of this was just moisture being brought and orographically lifted. You can see that. There's even a line of just completely snowy to no snow at all, just in the lee of the Front Range here. So that's interesting. And then the last thing I'll point out is we'll see this on the current satellite, but look at all this cold air advection off the East Coast. So this was a cold front that moved through. This was our Wednesday snowfall. You can see it march across the eastern portion of the United States, and in its wake, you'll see there's cold air advection over the ocean. There's the Gulf Stream, so it's particularly warm, usually, especially compared to really cold air. So you'll see cloud streets form. And we'll see that predominantly in the current satellite here. You can see all these streaks of clouds. And they extend from where it's really cold out of the ocean and then hit the cold front, which is what's helping to produce them in its wake here. So that's a recap of what happened. It was a lot more interesting than last week, which is good. Could we go to our current US satellite, please? So take a look at what's currently going on, because there's a lot of things that we'll point out here. We'll set the stage for our snowfall event. Can we do the CONUS, actually? Because there's several features I want to point out that you can't really see when it's zoomed out here. Okay, so first, look at all these cloud streaks. So these bands of really cold air moving over the warm ocean, and they can conglomerate into these little bands of probably producing light snowfall over the Atlantic. In the wake of the cold front, you can see a really thin cloud at the leading edge of this cold front. So this is making its way and extending all the way into the, sort of the northwestern portion, even maybe the central Atlantic. That's how extensive this is. Some of this, we'll see this in the radar. So you can see an anticyclonic swirl to it. So this is cold air coming off the continent and swirling around and behind this cold front. The same cold air advection is producing some precipitation in Florida. So you can see these cloud streaks are moving, and they're making landfall, if you call that, in Florida, and producing rainfall, which is kind of cool. We'll see that on the radar here. In its wake, you can see a lot of snowfall, particularly here's the Appalachians in West Virginia and Pennsylvania, and then a band of snow that moves central Virginia here. So that's all snow cover. Same thing with Canada, northeastern United States. You can see everything that's not moving but white and really bright, that's all snow cover. You can make out some lakes that are completely frozen over, especially this one right here. Other than that, you can't really tell what's going on the ground over much of the CONUS because there's just clouds moving over. So a lot of cloud cover from that system, and you couldn't really tell, but there is snow cover. You can see this band of snow that extends from Ohio all the way into Kansas, Nebraska. Everywhere north already has snowfall. You can see that right at the beginning, and then there's just largely clouds essentially over much of the western portion of the United States. You can see our moisture from the system. So it was moisture that came over the Pacific, moved inland, and there's some moisture flow from the Gulf represented by these lower clouds here. So those are combining to produce our moisture and our snow system that's going to bring us snow going forward here.
The day cloud phase RGB image really helps to isolate the snow versus the clouds.
Oh yeah, we can show that if you want.
If you're done with this.
Yeah, go for it. I don't typically use that because I'm colorblind, so I can't see these pretty well, but...
So, sorry, yeah, but
that's fine.
For those who can see, the really bright green, like the lime-colored green is snow. The sort of cyan clouds are low liquid clouds.
Okay.
The orange and yellow tend to be higher clouds.
Okay.
And then
So I can see that. Here's the lower clouds coming up from the Gulf. You can see that extend all the way into Nebraska, Iowa, Missouri. Looks like.
Yeah.
And the higher clouds. So yeah, useful tool.
Anyways,
Okay, let's see.
you can see that the stuff off the East Coast too is mostly low cloud.
Yeah, that's
Except
right.
right along the front, there's some higher stuff.
That's right. Yeah. Can we look at the current radar, please? So I'll point out some of this. You can see it'll be a mess over the western United States here. A good mess to have. So all of this is essentially snow going on. Lower elevations are getting rain, but all of the higher reflectivities are essentially snowfall. Here's our system. It looks unorganized via the radar and via the satellite, so it's mostly just a push of moisture and will become something later on as it moves eastward, but right now it's just kind of a blob of moisture. Here's what I was talking about with the cloud streets. So we had that cold air advection wrapping all the way around. Here it's producing some rain, these little speckled rain showers over Florida. Same thing, same cold advection. That same cold advection is producing lake effect snow. You can see predominantly around the Tug Hill Plateau. They've had about close to 300 inches of snow at one of these cities in the Tug Hill Plateau. 300 inches of snow. That's pretty ridiculous, I think. It's not a record snow for them. This is pretty average. Which just imagine that, how much shoveling you have to do. And some of these things, like it'll be snowing for 5 days in a row, and then you get 1 day break, and then it snows for 5 days in a row, and just crazy. But yeah, not anything abnormal for that part of the country. What else? We had this like band of returns move through, but I don't think it produced any real precipitation just because it's so dry currently. We'll take a look at that in a second here, but this seems to be the beginnings of what will be our snowfall, these higher reflectivities, and we'll see if any of this is hitting the ground. I'm sure some of it is here. So can we take a look at the surface, please? We'll verify some of these radar returns here. We'll look at our surface map. So first, looking where we saw that the radar reflectivity, it still seems pretty dry. A lot of these dew point depressions are greater than 10 degrees Fahrenheit, so it doesn't look like anything is hitting the ground yet. Maybe something near Omaha, but the stuff that moved over us is definitely not hitting the ground. We have pretty high Fahrenheit, 4 degrees dew point here. You can see that we have generally southerly flow, so that's bringing up all the moisture, relative moisture from the Gulf here, out ahead of what is sort of developing into a cyclonic circulation, but not anything really coherent at this time. 50s in Denver, so they don't care that it's snowing over us because it's 50 degrees. Pretty nice day, pretty nice Valentine's Day for them.
Heavy snow in western Colorado, though, like
Yeah,
shown on the satellite.
Exactly. You can see here's the front range, so heavy snow, cloud cover. On the lee, 60 degrees, sunny, nice day. Terrible February day for them, 60 degrees. You can see all of the rain, snow, speckled all the way over anywhere in the west, essentially. We've had kind of this really cold mornings and then just quickly warm up, and then it drops really cold, and that seems like what's happening again. We got -4 overnight, and now it's already 16, so relative quick warm up. And then here's that heavy snow in the Tug Hill Plateau right there. Other than that, I think that's all I want to point out for the surface map. Could we go to the super peaks, please? Here. So we'll look at the jet stream first, and this will tell us sort of the picture of what's going on here. So currently we have a very wavy pattern relative to what we had last week where it was just zonal flow. We didn't have these big amplitude waves. It was mostly zonal. Now we have a couple waves moving through. So here's a trough. This was part of the system that moved over the western United States, is bringing some of our snow developing. You can see here's another wave right way out here, right downstream of it. This is our system that brought us the snow on Wednesday. It's way out just south of Greenland now. You can see a really nice jet streak, pretty fast wind speeds. You can make out we had a dip in the jet stream. It was really cold. Now we're getting into a slight ridge, and so it's warming up relatively. But then in its wake here, we have another dip in the jet stream. Here's the next shot of cold air, really cold air coming straight from Canada. Weird, there's a easterly flow to the north, and then westerly flow to the south. So that system that developed over the Atlantic, moved up towards Greenland, kind of reversed the flow up over northern Canada, and that's what it dislodged our cold air and is bringing it south. And we'll see that reflected in other maps here, but interesting, you don't see easterly flow up in Canada, and a pretty wide range of easterly flow over much of northern Canada has that, going into even, looks like portions of Alaska, so weird. Definitely not super abnormal, but not something you see every day. Places, okay, let's look individually here. So Valentine's, Virginia, which is right here, is in a left jet entrance region. So by jet dynamics, they might experience a pretty nice day, general subsidence. If we go to Valentine, Texas, which is right around here, they're in a bright jet exit region, so there's also general subsidence over that region. If we go to Valentine, Arizona, they're sort of in this, maybe they're in a exit entrance region, but they're kind of just plopped right in the middle of this jet stream. Valentine, Nebraska, right around here, is sort of in the jet left or right jet entrance region. Not really particularly strong speed change, so maybe no forcing for anything up above at 250 millibars. And then if we look at Romance, Wisconsin here, and that's the end of my list because that's all I can remember, they're in a sort of right jet entrance region, some uplift. Definitely might be a snowy day for them. And that's right near the Minnesota border here. So a couple cities that I wanted to point out for the holiday: Valentine's, Virginia; Valentine, Texas; Valentine, Arizona; Valentine, Nebraska; and then Romance, Wisconsin here. We go to 500. We'll see here, very interesting system sitting over the maritime provinces. So what I want to point out here, first we're in a trough pattern. So if we draw the trough axis, it's kind of completely flipped from being straight zonal to meridional. We have nice southerly flow, and behind it, we have pretty good cold advection. These are like minus 35, minus 38, and you can see the temperature gradient associated with this trough, very strong, especially around this trough axis. So there's pretty good cold air advection and cyclonic shear, which will become important in a second here. I'll point that out, but sort of the same thing we saw. We have this system, this is our really cold air moving southward. We have easterly flow again in Canada, stretching into Alaska. So definitely weird. Over us, here's our trough that brought us the snow. We're in this slight ridge pattern, but you can see the trough that moved over the western United States, bringing that unsettled weather, bringing that eventual snowfall for us. Not particularly strong, especially compared to this trough, but enough to produce just unsettled weather for a lot of the United States here. And then you can see the last thing I'll point out, the like really, really cold air is right around this Hudson Bay low. And so as this rotates south, all of this cold advection moves southward. This is going to be our shot of cold air just on the western portion of this Hudson low here. Okay, going back to this, and this will be the last thing I talk about. We have this really strong cold advection, so minus 35 blowing straight into these isotherms here, so that's cold advection, and the winds are turning cyclonically, as you can see. So that's cold air advection, cyclonic shear. That's a subsidence regime here. So we have sinking going on where we have this really strong cold air advection. What that does, we have a trough, so we have decent vorticity we can make out just by the curvature and the speed change here. That subsidence is bringing down stratospheric air from the tropopause. So we bring that tropopause air down. It's really high static stability, higher potential vorticity. That manifests as increased vorticity at the base of this trough. So you're enhancing the vorticity, which enhances things like PVA by the thermal wind out ahead of it, because you're increasing the vorticity. It also brings down potential vorticity anomalies, and those can interact with the surface, and you get increased development from this trough here. So if we go to tropical tidbits, and we'll take a cross section through this, and that'll be the last thing I show here. You can see this manifest, which is pretty interesting. If we go to regions at the bottom, and if we do, I think I was using North Atlantic, and let's do upper dynamics, I think it is. I want the 500 vorticity. Yeah, I think it's at the bottom here. Right there. And then if we'll have to step back, because this always steps forward for whatever reason. So if we could go to like, I think hour 6. Yeah, here we go. So this is the same trough, just in model land. It's pretty good. it's matching up with what we saw. You can see this really nice strip, higher strip of vorticity right at the base of that trough. That's due to that cyclonic, cold air advection and cyclonic shear, the sinking of that high PV air down. If we take a cross section now,
Wait, this is a week old.
That looks old.
oh, you're right. The picture is exactly the same. Not exactly the same. We go to like hour 0. Yeah, look at that. So that's why I wasn't confused. But right there, you can see there's largely just higher vorticity. That's the shading. Right at the base of it, here's that enhancement. If we take a cross section now through that enhanced vorticity, perfect. And we'll do PV, please. Look at this appendage of high PV down all the way into the middle troposphere, getting into parts of the lower troposphere here. So it's all the way down close to like 650. This is all really high PV air. This manifests at higher vorticity at 500, but then you get these, anywhere you have a PV anomaly, you will get a cyclonic circulation anomaly, and these things can enhance PV anomalies at the surface or cyclogenesis at the surface. Anything like that. So anytime you have this really high intrusion of really strong PV down towards the surface, you can expect there might be a strong development out ahead of it. This cross-section we took is out over the Atlantic, and so what happens is you get really strong cold air, it moves over the Atlantic. The Atlantic's like a hot plate. It's essentially free moisture, so you can get really strong development based on where these things move, where they set up in relation to troughs that are already set up there. So if we exit out of this, we'll see just where we expect. So here's a really strong area of vorticity here. If we go to precip and moisture, and just MSLP and precip, you'll see right ahead of it, exactly where you'd expect. Here's our really strong cyclone, 975. And if we just step forward one time, you'll see, because of where it's set up, we have nice, sorry, go back one, sorry. We have a nice thermal gradient, so all of that vorticity is being advected by the thermal wind right where that cyclone is located. One step forward, we'll see it deepens 6 millibars and keeps deepening if we just go one more time to a 965 storm. So pretty strong. And that was our Wednesday snowfall, that same system there. And you can see a really, really intense cold air advection in its wake. Look at this gradient and mean sea level pressure. We go from 965 to 1039. And that's represented by all these isobars in between the really intense air. Strong flow straight from the Arctic all the way down over the Atlantic. So that's something to watch too. Where does this thing go? I won't step any more forward, but something interesting going on aside from our precip we have here. That's all I have. Is there anything anybody wants to see or talk about? Yep.
So in thinking about what's going on with that easterly flow over Canada,
Yes.
can we look at like a polar map? I don't know. Maybe
Yeah,
check-
Northern Hemisphere one goes to.
Yeah.
Cover.
Whoa.
Yeah, okay. So, yeah, this is really interesting. It's been a collection of ridge building in both the Atlantic and the Pacific that have really pushed the cold air off the pole
Right.
into the mid-latitudes, and we're gonna see the impacts of that for a couple of weeks.
Yeah.
Yeah, we have this blob of cold air right there.
It's coming, the regime change.
Yeah, I thought I remember that.
We were talking about that high over the North Pole last week, right?
Yeah.
There was a
That's
ridge
right.
over the Pacific that sort of forced an anticyclonic flow to the pole.
And it's currently in the process of impacting the stratosphere. So right now, the stratospheric polar vortex is record strong. And so over the next couple of weeks, we're gonna see it rapidly decelerate, and that's gonna have implications for the next couple of weeks worth of weather.
So it's gonna be cold.
Imagine, is that true or not?
So it's interesting, if the vortex holds on long enough into March, this could be our final stratospheric warming, and basically what that means is that it becomes summertime in the stratosphere, but that would mean an early spring.
Yeah.
So that would be a early spring transition theoretically.
Better predictor than the groundhog.
It's weird.
It's
like
strange
somebody
that,
should
no,
do some
someone
research
ought to
on
think
it.
about that.
Yeah.
Better prediction than the groundhog.
Which one?
Yeah.
There's multiple.
I'll be damned.
Yeah.
Fair.
Although they might be the only people with jobs after.
Yeah. Oh, no.
Um, Yeah, anything else anybody wants to see? Okay.
All right, thanks for
Turn over
knowing.
to Fourth Grade.
And Andrea, I woke up this morning thinking, didn't we talk about this 2 weeks ago? And I'm glad to hear that we
It's
did.
the long weeks, they're slow, they last a few weeks.
Thanks, Patrick, great job. I don't have any cities like Bad Romance, Nebraska or anything like that to point out. But I do want to tell you, before we look at the forecast, because the forecast is really going to be about where does this cold air go and how extreme. And it's related to the snow that we're likely to see this afternoon and probably through a good part of the day tomorrow, although it's really weakly forced, so we'll take a look at that. But this is the cold pool through the 13th of February. One of the more volatile years that I've ever seen. Usually, it's sort of, has a couple of these big swings, but this is 1, 2, 3, this is the fourth one that we've seen. Actually, maybe the fifth, arguably the fifth one in just, I don't know, was it 60, 74 days? So the time scale of each of these buildups has been very small this winter. And I forget when and what I did, but I measured the volatility the same way you'd measure the volatility of the stock market indices. And there's nothing that I can see yet in volatile winters compared to non-volatile winters. I thought there might be some circulation differences, but they're not really substantial and maybe not significant. But anyway, we've just barely crawled into a portion within a standard deviation of the daily mean here in the middle of February. We're the fifth warmest. That is integrated departure from average, means the fifth warmest one since 1948-49. I think we have no chance of getting number 1, but we do have a chance of getting number 2, 3, or 4. That's not impossible. Maybe especially as the poles really warm up and maybe stay warm for the next 2 weeks. It could just be the peripheral cold air is going to be beaten down, and we may see this thing drop in the face of that. But we'll have to wait and see on that. But right now, fifth warmest through the 13th of February. We were the warmest September, October, November ever. So I think the sum of pre-winter and winter this year may be the warmest 6-month period ever in the Northern Hemisphere in this 77-year record now, which is interesting. And we just heard this week from Stan Benjamin at NOAA that Arctic sea ice, often reported in late September at the minimum and early March at the maximum, is way, way below normal right now in February. And so I hypothesized with him that maybe it's the really warm fall that gave it bad sea legs at the beginning of the season, and it hasn't really been a very good cold season. There's been a couple of spots. This one here is amazing at the end of December. 7 straight days of all-time record minimum of the 850 millibar cold pool area. We've only had one other such day this year. But that was just stunning. And I think that probably did damage to the initiation of the ice cover. And it's not really recovered because it's been too volatile since on the hemisphere. I don't know about the high latitude. You could use maybe minus 15 or minus 20 of them. That would be cool to see, what's going on there this year. Because that's probably more proximate to the Arctic ice. But anyway, interesting. Story's not told yet. We'll get 2 more weeks and see where we end up. But I'd sure love to crack the top 3. And after having the warmest fall, that would be just awesome. That'd be almost hardware for me. I know there's Eagles fans in the crowd. They're all excited because they've just won championships. This is my version of going for it every year. Not quite this year. So, okay, can we go to the? I'd like to go back to the super beats, and particularly 700 millibars, the often neglected 700 millibar map. I think it's going to be something to look at for this coming couple of days, although it doesn't show the signal that we'll see in the forecast. This is what I'm thinking about, is this confluence region, which is now currently upstream of us, but the whole pattern is moving, and this thing is largely structurally preserved as we move into the 24 to 36 hour range. It's confluence coincident with a really intense temperature contrast, as we've kind of seen from a number of different ways, so that's going to have a phrenogenetical impact on the flow, and I think that's what we really are going to benefit from on Saturday. But it's really weak and not really settled in all of the forecast models, at least as far as I can tell. Our immediate threat, though, is this feature right here of kind of concentrated warm advection, which as Patrick pointed out so nicely in the radar in his discussion, that's where things are starting to really take some shape in this otherwise almost amorphous structure that we see just to our west in the radar. But that local region of warm advection is really strong forcing for strong ascent. And I think that's probably the feature that we have to worry about for our rush hour and into about 7 or 8 p.m. tonight. That'll be an inch an hour or something, the weather service is talking about. But I put my finger on that as the reason. And I think it's really cool too that you can see the confluence of a couple of different circumstances perhaps that are kind of putting this together. One of them is, this is a conspicuous sort of warm bubble right here in the Central Plains. I think it's probably aided by some lee-side subsidence. So that makes this warm, but then the northeast periphery of that warm bubble is an immediate spot of warm advection. And then it's running into this kind of stationary, deep cold air. So that there's going to be a tendency for frontogenetic action on top of just the long isentropic Q-vector convergence here. So that all of those ingredients are in play, it seems to me, but in what proportion and at what time is what's a mystery, because this whole thing is kind of weakly structured. So, but I put my finger on this for our afternoon snow event, and we'll look at that in the forecast. And then for later into Saturday, I think it's this confluence on top of the temperature contrast that's going to be the thing that continues the threat, to deliver the threat for us. And just before we go, that's a beautiful cold frontal baroclinic zone. Isn't that gorgeous? What an amazing storm. And the one that Patrick so nicely showed went over the pole from our midweek was also beautifully structured, and it was an absolute beast off the Canadian Maritimes. And I'm wondering, Andrea, if in flows that are kind of broadly zonal across the country with a little bit of a dip, if there isn't assistance from something in the high latitudes, they can't get really wrapped up. This thing, for as strong as it looks, it won't really get wrapped up, I don't think. And the next one that comes through certainly won't. That'll be a pretty heavy rain event in the southeast, and maybe severe weather event, but it's not going to wrap up. And I think it's because there's no way to deal with the stretching that's going on when this thing becomes so strongly southwest to northeast. There's no way to do it unless you bring in some other vortex structure from high latitude. And this thing's cut off, so there's no more chance for that to happen. So broad speculation, but it's kind of talking about the ingredients that we hope to look at. Were this year a nurture year, we'd already be done. We'd be coming home. I mean, with all the prizes we won. I think you would have loved to be in that storm up over the northern part of the Labrador Sea and see what's going on in the stratosphere. I think that would be
All the
the best part.
observations would be, you know, I was just thinking, we have a really, really strong stratospheric vortex right now. With
Yeah.
this easterly flow at the tropopause. So what is that?
Yeah, right.
Really strong
What does the shear look like? What does the temperature contrast
Yeah,
look like?
right.
Yeah, that's a really interesting question. Can interrogate it to some extent with the data in models,
Right.
but you'd love to get a few in situ observations of such an unusual event. Okay, Pete, can we go to the forecast panels? Let's use the, I'd like it to be maybe the 104 grid is rather big, but let's just try it out first.
I'm working on getting the 80-kilometer one going in
Okay.
the same thing, so.
Let's go to 8:50 at 6 hours. So that'll be tonight, right? Is that, no, this is now.
It's now.
Let's go to 12 hours. I mean, 18. So this will be midnight tonight. So we have, here's the temperature contrast for the first event. Actually, Pete, we have to go back to the prior one. I'm sorry, I said the wrong thing. Let's go to the 12-hour forecast. That'll give us
Why
an
don't
idea.
you want me to bring up the loop and you can just flip it?
No. The loop is mesmerizingly confusing. This is better. So this is 6 p.m. So strong warm advection, and if you look carefully, it's localized. So the wind speeds here, which are approximately geostrophic, are much stronger in this channel than they are astride. And that means that there's a lot of a long isentropic Q-vector convergence here, which produces not only a thermal ridge, but also ascent. And so we get a little bit warmer as this thing approaches, even though if you looked at this without thinking about that process, you might say, wow, this is kind of a broad baroclinic zone. It is. But there's a local maximum and warm advection right there, indicated by the strength of the winds across the kind of uniform gradient all the way up to Lake Superior. So there's strong ascent there. That feature is currently in central or southwestern Iowa, so this represents a progression toward the northeast. That's why I think this will be our snow producer for tonight, late this afternoon tonight. But then, broad region of cold air to the north in Canada, but then here's the gradient again. It's kind of sitting right in this location. There's not much surface development. There's the little bit of lee side trough warming at the southern end, but it's not really much surface development or near surface development there. Let's take a look at 700 doesn't do it. 500 millibars at the same time, Pete. And at 500 millibars, there's almost no vortex structure at all in our region. I mean, a broad region around Wisconsin is not much vortex structure. There is, however, an axis of dilatation right there. And so there's strong confluence from the north and the southwest, and we're perfectly positioned at 500 millibars to be on the warm ascending branch side of whatever might come of a frontogenetic response to this confluence. And I think that's the thing that adds on top of the underlying tropospheric warm advection to give us a pretty decent threat. This feature here is what the Weather Service has its eye on for later in the day on Saturday. We'll keep track of that as we move forward as well. But starting for tonight, I'm thinking I like to be in this position, slightly on the warm side of the axis of dilatation. That's a really good place to be, especially when it's 16 degrees out right now. It's not going to warm up to 35. Okay, let's go ahead 6 hours, Pete. And let's go to 850 first. So at 850, strongest warm advection is to our south by this time. And this is one of the things that bifurcates in this first part of the development. Things get a little bit more interesting to our south and our southwest as we move from Friday into Saturday. This is midnight. And, but there's still differential cold, warm advection over us. And so I think there's still going to be a tendency for some frontogenetical activity in our vicinity. I've checked it out in GEMPAC. It's very weak, but it's not zero. And it does have some vertical structure. It's not very deep either. So it's kind of weak. And by midnight, I suspect our first big snow push, not only over us, but it's disappeared entirely. It doesn't last very long. It lasts long enough to, I think, braze us. But the next thing is, what happens to this currently, I mean, forecast time, elongated upper trough? Remember, we have that vortex structure at the earlier time down over Arizona and Southern California. That feature is also making eastward progress. Maybe it begins to be involved in this development. And then the other thing I want to keep an eye on when we go to 500 millibars is what's the downstream setting? Is there any chance for a ridge building in this location, or is it just going to be a trough that propagates through the base of a trough and rolls up on the other side of a really broad ridge? In which case, it can't wrap itself up. So let's go to the 500 millibar forecast at this time, Pete. So for question number 2, that's a long transect of pretty much straight west-east flow. I don't like that. I don't like it at all. I'd like to see, it's amplified by another vortex strip to the north. It's going to be really hard to build a ridge in the middle Atlantic downstream of this upper trough, which probably means anything that does develop in response to its presence zips along to the east and doesn't really stick around very long. But again, we are still kind of at the axis, or just south of the axis of dilatation of this kind of broad deformation region. And we know that it's baroclinic across the central plain states. So by the time we get to midnight, maybe we start to be the beneficiary of some weak confluent frontogenesis in the middle and upper troposphere that keeps the snow going, though perhaps not at the rate that we are likely to see this afternoon. And then this upper trough vortex structure is going to be something we keep our eye on. Very often, however, you bring in some of these vortex features into such a confluence zone with this kind of length and so much deformative stretching. It's like a meat grinder for that upper vortex structure. It doesn't really portend well for that. So cyclogenesis seems less likely than precipitation generation, and we'll see if that's the case. Okay, let's go ahead 6 more hours if we could, Pete. So this looks weaker and weaker. There's almost no flow over the gradient. We stay cold enough for any precipitation that might fall. It's going to be snow, though. The main action shifts to our south by the time we get to early morning Saturday. This is pretty strongly the same kind of thing that we're talking about for us this afternoon, a local region of strong warm advection. Probably because it's so warm, I'm going to guess that it's also relatively moist with the flow coming off the western Gulf of Mexico, that we're going to see probably some really heavy precipitation in central and southern Illinois and then southward towards Cape Girardeau-ish, Missouri, and across Kentucky. And we're starting to see the cold air in the lower troposphere fill in as probably the upper trough has swung a little bit further to the west. Meanwhile, our cold pool just to our north is congealed with temperatures in the minus 34 or 32 range just off of Churchill, Manitoba. No place to go but down across the western Great Lakes states. If it stays that large, I think it actually continues to shrink. And there's our storm in the Maritimes just south of Greenland. Very intense circulation and widespread. Look at that thing. It would have been great to sample that. Beautiful cold frontal structure that becomes part of the baroclinic zone that's now south of us and becoming the main feature for precipitation, I'm gonna guess. After we go to 500, let's go to the surface map at this time too, Pete, to see if that separation starts to really show up between the two precipitation features. So here's our upper structure associated with the big storm over the southern Labrador Sea. Really intense vortex strip. I don't know what that looks like in the vertical cross-section. Kind of interesting to look at. But still, very hard to put a ridge downstream of this invading upper trough. I think the cyclone was over the southern plain states in position, relatively speaking, to the curvature, and there's a lot of probably shear vorticity mixed in here as well, only a little bit of curvature. And we start to get a fairly elongated vortex line. And then speckled regions of really low vorticity next to high ones. Undoubtedly, that's convection that's showing up in the model, so we'll see that when we go to the forecast. Surface precipitation. Okay, so that's the structure. This is slightly positively tilted trough, which is also not good for getting the whole thing wrapped up, so everything's kind of working against a major cyclogenesis event over the continent. Can we go to the surface map, Pete? Just beginning to see this precipitation breaking out in the forecast over southern Illinois, sort of the southern part of the Ohio River Valley there. And a little bit of lingering precipitation over us. There is an inverted trough, probably has slight frontogenetical characteristics in the lower troposphere, since the geostrophic convection of thickness is differential, tending to intensify it, and we're on the warm edge of that. This whole band of precipitation is, but it's weak. But nonetheless, I suspect it'll snow through Saturday morning, Saturday afternoon, which I don't care. We're getting 4 inches of snow tonight and then a little bit more falling. It's okay with me. I'm happy with that. So, but the main event starts to take shape maybe over the southeast, south and east of us, I should say, not over the southeast. Let's go to, let's keep going at 6-hour increment speed, because it is kind of a quickly evolving system. There's our cold pool. Again, not much flow over us, a little bit of warm advection over us, so that means probably a continuation of that threat of light snow. Things look a little more interesting down over southern Illinois, Boot Heel, Missouri, western Kentucky and Tennessee. And really I want to see, I'll keep my pointer right there for where the cyclone is. Let's see what it looks like at 500 millibars. Yeah, rats. You don't like to have your sea level pressure minimum elongated in the same direction as the upper vortex strip. That just means that there's not really any cyclogenesis going on. And that's unsurprising. Maybe there's a little bit to the south because it responds to the curvature maxima down here, and so there's going to be a little bit more concentrated ascent right there. But I think that this vortex strip is really testifying to a deep baroclinic structure and not really to a cyclogenetic structure. Let's save that and take a look at 30-hour forecast and tropical tidbits. We don't have to do it now, Pete. Let's just keep going through this whole thing. I'd like to see this first. So maybe we'll see what the surface precip is. Yeah, see, look at, now we're starting to see things kind of get a little more interesting in terms of amounts, probably also convective nature in this location. And that's not surprising given what I think is setting up. And the thickness field gives it away. This is a broad baroclinic zone through a deep part of the troposphere. It's not just a surface baroclinic zone. And so that's, and this portion of it is frontogenetically active. It's fueled by probably poorly stratified air, certainly moist air from the Gulf of Mexico. And there's probably heavy convection across Kentucky by midday tomorrow. Okay. Can we, I would like to see what this looks like along a line like that in tropical. Just to, and then we'll do the one through Kentucky too. That'll be kind of fun. It's dizzy, but it works. Conus will probably be okay. Let's try that. Okay, and then so one of them, I'd like to kind of, is this the same time?
We gotta go, what time was that, 30?
18s, two more 6-hour clicks, yeah. So maybe right through there. Pete and I agree that long cross sections are the big aspect ratio. Now let's look at the frontogenesis, and especially I'm looking at the theta in this case. Oh, theta E. Really weird structure. Not much frontogenetic activity. Poorly stratified, so you get these big plumes of ascent. Let's look at theta instead. So there'd be the PV maybe. That's really interesting. I thought I'd see a little bit more baroclinicity at 500 millibars. It's very weak, and this feature is completely confined to the really upper troposphere, 400 millibars and high. That doesn't surprise me, but I did think there'd be a little bit more residual baroclinicity down there, and frontogenesis along the theta gradient, but there is none. So that's interesting. Okay, let's get out of this, and we'll take one through central Kentucky. Even though the guidance at 500 millibars is poor for that, let's do it right there. So my suspicion is this will be lower troposphere frontogenetic activity. Let's see if that's right. Boy, nothing. So how do you explain this extraordinary updraft, which for sure is the reason why there's heavy precipitation in central Kentucky along this line? What is going on there? I don't think I quite get it. This is theta E in green, so it's poorly stratified. That's one thing in its favor. It's really bad stratification. But you still got to force the air to rise. And I don't think I understand why that's happening there. Very interesting. Anything else could give us a clue? Let's take the PV. I don't think we're going to see anything in the PV. Yeah, nothing, except the reflection of the convection, which kind of pushes the tropopause up. It's stuffing it back to higher elevation. Very interesting. All right, maybe something will come in the next time. So let's go to 36 hours, and maybe that's where we'll stop. We'll get close to the end. So, thinking about this region of kind of, which was interesting and somewhat confusing. There is now really strong southerly winds on the warm side of this baroclinic zone, almost none to the north. So that's strongly frontogenetic. Maybe tropical tidbits, contour intervals a little bit too weak, but that looks strong by the eye at 850 at this next time in the sequence. And then really cold air funneling straight down. That's exciting. I love to see people in Texas get a little nervous and getting cold. Not desperately so like February 21 when their senator left the state. I mean other times, just so that remember that they're part of this country and it gets cold in a lot of our land. Let's go back to 500 millibars. Are we at 36? I think we are right here. So here's, again, that speckled positive and negative vorticities like Matt and Shelley have been talking about. If you have an updraft that's really intense, you're going to create little vortices, negative and positive, that straddle each other through some region of the atmosphere. And that looks like a signal of convective line. And then here's this upper vortex structure that is coming into the region of now weakened confluence, but it's still kind of confluent flow in that region. It's not going to survive. But this is really making me think we're going to see a really strong precipitation signal in the next panel at the surface in 36 hours. And somebody was asking me in class today about the severe weather threat down there. I hadn't even thought about it. Yeah, it starts to look a little more interesting. So this is maybe the same feature that we saw at the earlier time in Kentucky, and then it's got an appendage that heads to the southwest. Still a weak cyclone or central pressure. This is 1,000 millibars right there, and it's elongated in the direction of the baroclinicity. It's got no chance of really developing very intensely. But maybe one more cross-section, Pete. Let's see what this one looks like from Chimney Rock, Nebraska, down southward at this time. So from here, maybe to, down into, I don't know, central Mississippi or something. See what that looks like. That's a little more robust. I can understand this now. That's really strong frontogenesis. And then you've got this updraft that's just off the charts. It's in the 6 or more pascals per second, so that's 60 hectopascals, 60 decipascals per second. It's like 60 centimeters per second updraft. And that seems to be responding to intense lower tropospheric frontogenesis. So let's take the PV so we can see this in theta, and that's between 35 and 34. They don't all use the same aspect ratio, but I think they use the same mass. Yeah, so no, not much temperature gradient. That is so interesting to me. So this is as much frontogenesis as you're going to get out of vertically oriented isotopes. I've never seen anything like it. It's really strong in here, and the response is this big updraft. And here is not the updraft. This is just negative PV, and that's where the updraft is. So it's destroying the tropopause above it and producing a really intense convective line right about in that location through central Arkansas. Okay. So there's a lot going on in the central part of the country. We get some snow tonight, this afternoon and tonight, probably more snow tomorrow, and then we have to keep going at 850 just to see the temperature change in the wake of our weekend snow. So let's go to the 850, then we can go to a movie and step through it. I don't want to just let it loop, but we can step through it. cat's away and the mouse won't play. I don't know what's going on. Thanks. And they'll stop. And we'll just step through. So this is about the time we ended early in the day on Sunday. So here's the cold pool that's shrunk, and but still minus 33 is cold. And we'll watch where it marches. Sliding southward through Ontario, coming across the border into Minnesota, North Dakota, loses a little bit of its potency. It's not minus 34 anymore, it's minus 31. Let me remind you, we live here, and we'll keep on going. So that a modified version of air that's well below minus 25 C is kind of poised to slide across us by the middle of the week. Actually, it's still hanging to the west in this forecast. The other one I saw kind of slid a little bit more to the east. But this is still really cold, bloody cold. It's dark red, and I think that's like minus 28, so this is minus 24 at 8:50. And with fresh snow on the ground, I think we should take a look at 2-meter temperature forecast from tropical. I'm gonna guess we have a chance at minus 15 or colder on Tuesday or Wednesday, which is very exciting to think about. Yeah, I think they have 2, let's do the contours. I think that's a better way. No, it's not. You had the right one, sorry. I always forget which one's better. Yeah, shading, because it actually gives you a few values. And one of them happens to be right over Madison. So this is tomorrow, 29, not so bad. The cold air is still lurking to the north and west. Now, here we go. Here we are on Monday morning, minus 7. Okay, that's pretty cold. Gets to, what did it get to, 2 for the high? Yeah, great, okay. Tuesday night, not quite at 2, Tuesday morning, minus 10, minus 20 near Eau Claire, let's keep going. 3 for a high on Tuesday, maybe 5, okay. Oh, maybe that's it. So Tuesday and Monday are the only days minus 7 and minus 10. So we might crack minus 10 according to the most recent forecast portrayed here. This is from the GFS, I think, yeah. Okay, I can't recall what my sense is about that. I think they often overdo cold forecasts. Keep an eye on the Weather Service. They might see the minus 10 and say it's going to be minus 18. On the one hand, they have local instinct and knowledge, and there's fresh snow, and I'm not so sure how well the model does with the fresh snow part. So minus 10 on Tuesday might be more like minus 13 or 14. Let me just say that. And I'll say minus 10 on Monday. So I'm going to go a little colder than this. So either way, very cold. That would mean maybe Monday is the day, no, Tuesday is the day the temperature may not get above 0, if I'm right. That would be nice. The record for my time here is 98 straight hours. That was February of 1996, temperature below 0. We will never see that again. That's over. Those days are gone forever, I think. So that's all I have. Are there any questions or comments or anything else a person would like to see? I have a hard time putting our discussion together in the spring, so sorry about that. Thank you.
Do you think there's any sort of like easterly jet up in Canada because you have like reverse barochronicity once the Arctic air mass gets displaced into like the northern tier of the U.S.?
There's certainly easterly shear. The question is there weakness in the flow that would allow there to be a manifestation of a really strong easterly jet? Probably not, because as Professor Lang was saying, the polar vortex is strong, so there's a huge westerly shear in the upper troposphere just from that. And you've got to erode all of that before you can show up with an easterly jet. So that's probably the answer, but I don't know. Anything else? Okay, thank you, Patrick. Thank you, Pete. See you all next week.